Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I tried something a little different the other day. I actually made a video live on a live stream. And it was kind of a fun experience because not only did I get a couple of videos made, you got to see me screw up a little bit. So it makes me a little bit more human. Now, while I've linked the raw footage to this video just for laughs, these are the refined versions of what I presented the other day. I've corrected the mistakes and updated them a little bit and added a little bit to them in post-production. So I think you'll enjoy them. So let's learn a little bit about selecting a slide rule. Today we're going to start off with the basic student level slide rules. In the second episode, we're going to do the engineering level slide rules. And in the final episode, we'll do some of the rare birds and specialty slide rules. So let's cue up the music and get going. So let's go ahead and get started. Well, I'm Bob the Science Guy. I have a YouTube channel, a couple of them actually, and one of the things that I like to deal with is something that is called STEM education, science, technology, engineering, and math. Well, nothing defined a mid-20th century American engineer as much as their slide rule, a pocket protector, pair of horn-rimmed glasses, a white shirt, and a skinny tie, and a buzz cut. That's my father. I didn't go into engineering myself, but I've always had a love for slide rules because I always thought that they were a fascinating way of looking at mathematics because you had a familiarity with numbers that you just don't get with an iPhone or a calculator or something. So I've done a series of tutorials on how to use a slide rule. And I go over all the different scales and the different types of slide rulers, etc. But I thought that I would do one overall video for people that are out there that are unfamiliar with slide rules to try and figure out what slide rule they might want to purchase, either to learn how to use one or to use for work. You can use it in a variety of things, be it figuring out how many cinder blocks you need for a wall, or building a bridge. The last major aircraft that was built using slide rule technology was the SR-71. During the 60s, we went into computers, and in about 1973, the electronic calculator came out at a price that people could actually afford. I remember my mother getting her first 4-function calculator, which only ran her $300 in about 1972. By 1975, everybody had an HP, and the slide rules kind of went out of style, and they stopped making them about 1975. There's only one company that I'm aware of right now that still makes quality slide rules. So let's just kind of pop over here to the desk and have a look at a couple of slide rules. These are basic or student level slide rules, and we're going to start off with this guy right down here to kind of just introduce the concept somewhat. And the characteristics of a slide rule are this. We have a body of the slide rule, and then we have the slide, and then we have the cursor with a hairline on it. The body of the slide rule is also sometimes called the stator. Now, this particular slide rule is designed for a specialty task. This is a conversion slide rule. It's not a slide rule like you would consider, but if you want to be able to convert meters to yards or meters to feet, square meters to square yards, etc., you can use a device like this. So for example, if we want to figure out how many feet are in 5 meters, we put the meter mark right underneath the 5, and then we read out here to the foot mark, and we come up to a little bit over 16 feet. Now, starting with that principle, we'll go on to an actual slide rule, and that's what these are. Now, a slide rule, again, has got a body called the stator. It has the slide, it has a cursor, and it has the hairline. You can see that's the common feature on all of these. These scales are what they call logarithmic scales. And when you take the log of two numbers and add them together, that is the exact same effect as multiplying those numbers. So for example, if we wanted to multiply 2 by 3, we would put the index line, which is the 1 on the slide, over the 2 on the stator. And then we'd simply read out to the 3 and get our answer, which of course is 6. Now to do division, what we do is we take the number that we're doing something to, in this case 6, and put it on the stator or the body of the slide rule. And then the number that we're operating on it with, say 4, we'll put that on the slide. So what this would do would divide 6 by 4, and then we would read our answer down here at the 1. And there we go, 1.5. That was my grandfather's slide rule. He was a civil engineer, graduated from Cornell in 1929, and then went on to head the Army Corps of Engineering Department of Hydrology in the Great Lakes. He was heavily involved in the Niagara River projects around the power stations and in the St. Lawrence Seaway. And when he retired in 1962, the year I was born, he attended the opening, or should I say reopening, the St. Lawrence Seaway, and basically had dinner with the Queen. Now, let's start off with this one right here. This is a very basic or student level slide rule. It's made by Sterling, and you can get one of these on eBay for less than $20. Now, there are a number of scales on the slide rule. The main scale is going to be the C and the D scale, and that's the one that we just used to multiply 2 by 3 and divide 6 by 4. The operation of that, we've kind of gone over real briefly, and I've got tutorials for that. But we have another set of scales on here, and these are the AB scales. The AB scales are half the length of the CD scales. And as a result, the relationship between these two scales, if you put the number on the AB scale, the square root will appear down on the CD scale. I'll show you an example of that because there's a couple little tricks. You don't even need to really use the slide for this because you can use the A scale and the D scale. But if we were to look at 9, on the A scale, we would look down to the C scale and the D scale and see its square root, which is 3. Now, there's an interesting trick that you have to remember with the AB scales. If it's an odd number of digits to the left of the decimal place, you will read that on the left side. If it's an even number, you'll read it on the right. So, for example, we just saw 9. That's a single digit number, and that's odd. Well, what about 16? 16 would be 1, 5, 6, and then we read down, and there's a 4 right there. That's the square root. 225. So let's go down here. There's the 2. There's 20 and 25. And if we read straight down, we find the answer is 1.5, which brings up another point. We have to figure out where to put the decimal place in here. And I've got a couple of tutorials, as I go through the different scales on the slide rule, that'll show you some aids in doing that. But the square root of 125 would be 15. That's the basics of a student level or basic slide rule. Now there's one more scale on here that's kind of an interesting scale, and that's called the CI scale. And that is simply the inverse of the C scale. Now the key to understanding the CI and the DI scales is to understand what they actually represent. On both the C and the D scale, the number is the log of x. On the CI and the DI scale, it's 1 over the log of x. So 4 times 6 is the same thing as 4 divided by 1 over 6. So on the CI scale, you read 1 over this number. And on the C scale and the D scale, you read the number. So, for example, if we were going to multiply 4 by 6, there's a couple of ways that we could do it. One way of doing it, of course, would be to place the index over the 6 and then bring it out to the 4 on the slide and read off our answer, which is 24. Now, to use the CI scale for this, we can do it a little bit differently. what we're going to do is we're going to take 4 or 6, I'm just going to use 4 for this illustration, and we're going to divide it by 1 over 6, which is the 6 on the CI scale. And then we just read off our answer again. Here's 2, here's 2.5, that's 2.4. The reason that you have a CI scale and a DI scale is simply for the convenience of the calculation. Sometimes it just may be easier to find your number that you're using on the CI scale, and you have to move the slide less. Now let's look over the next scales. We've done the CD scales, which are the main scales on the slide rule. We've done the CI scale. Now we're going to look at the AB scale up here. Now the AB scale takes advantage of a property of logarithms. So if you have log base 10 of the square root of x, that's the same thing as log base 10 of x raised to the 1/2 power. When you raise the number in a log to a power, you can actually bring that right around to the front, and that becomes 1/2 log x. Now, when you're dealing with square roots and squares, the relationship between the scales will be 1/2. So if the CD scale goes from 1 to 10, the AB scale, which deals with the squares and the square roots, is half as long and goes from 1 to 10, and then 10 to 100. Okay? Now, that leads to a couple of interesting rules, but first let me show you how it works. So if we were to take a number on the A scale, like 9, and we put our cursor over it and we read straight down, we get our answer for the square root is 3. Likewise, if we read up, we get the square of the number that's on the CD scale. So the square of 3 is 9. Now, we have a special rule that we use with the AB scale, and that is if we look to the left of the decimal place, if it's an even number of digits, we look on the right side. If it's an odd number of digits, we look at the left. So for example, here we would see 9 and 225, and over here we would see 36. So let's go ahead and have a look at those. So we've already done 9. Let's look at 225. That's down about right there. And if you look right underneath, the answer is 1.5 or 15. Likewise, if we look at 36, that would be over here. We'd go to the 36 and we read straight down, and our answer is 6. Now, what about the square of 45? So here's 4 and here's 5, and that's 4, 5. What's the square of 45? Well, we know that that's going to be somewhere between the square of 40, which is 1600, and the square of 50, which is 2500. So if we read straight up, it looks like it's going to be a little bit over 2000. You can check that on your calculator. That's one way of determining how many decimal places you have. We know the magnitude of the square of 40 and the square of 50. That gives us an idea of what the magnitude and where to put the decimal place when we square 45. Now, another scale that's on this particular type of a slide rule at this level, it's a basic scale, is called the K scale. Just as the log of the square root of x equals 1/2 log x, the log of the cube root of x equals 1/3 log x. So while the AB scale was half the length of the CD scale, the K scale is going to be 1/3 the length of the CD scale because it deals with cubes and cube roots. And we also have some special rules to deal with that. So if you're dealing with ones, you deal with the first section. If you're dealing with tens, you deal with the second section. And if you're dealing with hundreds, you deal with the third section. So it would go ones, tens, 100s, 1000s, 10,000s, 100,000s, millions, 10 millions, 100 millions. And it's pretty simple to do. We'll do a couple of quick examples for you. All right. So what's the cube root of 8? 8 falls within the ones. So we're going to use the first section, and we're going to go to 8 on the first section and read straight up, and there's a 2. How about something that's in the tens, like 27? Well, we come out here to 27. We read up and find the cube root is 3. How about 125? Well, that's in the hundreds. So here is 100. There's 20 and 5, and we read straight up, and the cube root is 5. Now, the final functions that I'm going to go over on these basic slide rules are the trigonometric functions. Now, you may notice that I have 2 of the same model of slide rules here, but they're slightly different. This one has your basic scales on it. Now, if you take this slide out and flip it over, you end up with this. And the difference between these two is that these have additional scales on them. They have an S, an L, and a T scale. Now, the S scale covers the sine and the cosine. The T scale covers the tangent, and the L scale is for the logarithm. Now, I'll show you how to use them kind of in reverse order here. We're going to start off with a logarithmic scale. Now, we know that log base 10 of 10 equals 1 point something something something, and that log base 10 of 100 equals 2 point something something something. Now, this first number right here is called the character, and the second part, the decimal part, is called the mantissa, because you know that, say, 42 will fall somewhere between log 1 and log 2. It's just a matter of what the decimal place is. Well, how do you figure that out? First thing that you do is you line up your scales so that the indexes all line up. You see, I've got my ones all lined up here. And then I'm going to go over here to 42, which is 4.2, and I'm going to read straight up onto the log scale. And that's going to be 0.624. So 42, log 42 equals 1, because it's over 10, 6, 2, 4. And you can check that on a calculator. That's what you use the log scale for. Now, the sine and the cosine scale here on the S will allow you to find the sine of a particular angle that you're looking for. But more importantly, it has a function on it called an arcsine. So for example, say we have a typical right triangle. Sorry, I've got a bendy side here. We'll just kind of ignore that for right now. Well, what are the logarithmic functions of this? Well, let's see now. Sine for this angle will be opposite over hypotenuse, 3 over 5, or 0.6. The cosine will be the adjacent over the hypotenuse, or 0.8. And the tangent will be opposite over adjacent. But what's that angle? We can solve that using something called an arcsine, arccosine, or arctangent function. Now, I managed to screw this up on the live broadcast for one particular reason. This is a Stirling slide rule. This is set up with a non-standard function for sine, cosine, and tangent. Let me show you a regular slide rule that's set up the normal way. Now, this is a more standard style slide rule. We have our sine function here, and then we have our tangent functions up here. The way the tangent works is that if you go up to 45, you'd use one scale, and if it's 45 to 90, you use the second scale. But we also have something down here called a sine tangent scale. So let's just start off with this first. So let's look at the sine of that angle. It's 0.6. We put our indexes over each other, and then we come out here to 0.6, right there. And then we literally just read off the angle. It's 36.8 degrees right there. So that's our angle. That's all it takes to find that angle. And you can do that for any of them. You can also use the functions for any of them as well. So if we go out here and look at the cosine, it's 0.8. So we'll go out here to 0.8. But because we're looking at the cosine on the S scale, we want to look at the red. So again, we end up with 36.8. Same thing with the tangent. We can actually read right up here and get the tangent, which is 0.75. And there's 36.8. Now, we have another scale on this called the ST scale, and that's right down here. This is the small angle scale. And the small angle approximation says that degrees divided by 57.3, which is the number of degrees in 1 radian of a circle. A circle has 360 degrees, but it has 2 pi radians in the circumference. So that will give you the angle in radians, which approximately equals the sine and the tangent. The cosine approximately equals 1. So for small angles, you read the ST scale, and that will give you the sine and the cosine and the tangent of that small angle. Now, when you're dealing with the main scale, your sine, your cosine, and your tangent is going to be 0 point something, 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 something. When you're dealing with the small angle scale, the ST scale, it's going to be 0.0 something, 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 something. And then if you get below that level and it goes all the way down to about 0.57 degrees, below that you're dealing with 0.00 something, 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 something. So let's take a look at this Stirling slide rule that I got confused with during the live broadcast. You know, it always happens during the live broadcast. So let's just go ahead and use the sine of this angle and try and find the angle. So we come out here to 0.6 and we read up to the S scale, which is this top one right here, and it comes out to what? It comes out to 21. What's the deal? This is what confused me. But then I got to looking at this slide rule. I see an S scale here and I see a T scale. I don't see a small angle scale. There's no ST scale here. So what's going on? This is not calibrated like a standard slide rule would be. The problem that you run into is this is where you read the sine. This area of the AB scale, the left side of the AB scale, is where you read the small angle approximation. So you don't put your 0.6 here. You put it up there. And if you read down there, what do you have? 37 degrees. So that's what happened. This was just an abnormal scale that I didn't recognize right away. But this is the beauty of a slide rule. You have to be able to figure out what's going on. And just by looking at it for a couple of minutes, I was able to figure out what they had done, and they had changed the scale up here. Now, while this slide rule that we've been using would be very nice for a mason or somebody who just wanted something in their desk to do quick calculations, these other slide rules are more engineering slide rules for people that use them for a living. And in our next episode, we're going to go over those more sophisticated slide rules when we look at the engineering slide rules. So until then, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by. I hope you enjoyed this brief presentation, which was pretty comprehensive for basic slide rules. Now join me next time where we go over some much more capable slide rules and ones that are really good if you want to learn how to use them. Remember to hit that like and subscribe, and once again, thank you to all my Patreons and supporters of this channel for making all this possible. Take care, guys.
please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Above the science guy, above the science guy.